Hi guys, today we're going to do reverse chain rule integrations, and the two things that I want to look at are these two rules here. So it's the reverse chain rule. The second one's really a special case of the first one, and these are really just differentiation but in reverse, which is hence the name. If you were to differentiate this using the chain rule, outside function first, that's f dash of g of x times the inside function differentiated, which is there. So if you differentiate your answer, you should get the integrand you started with. So that's proof right there anyway. Same with this one. If you differentiate that, that one comes down the front, cancels this one, minus one, that's an n, times the derivative f dash of x, which is that. So that's the rule proved. We're going to do a substitution proof as well. So here we go. The first one. After this, we'll do some examples. If you put u equal to g of x, du is g dash of x dx. So the left-hand side changes to putting all these substitutions in there. F dash, the integral of f dash with respect to u, integrate that, you get f of u, and that's it. Similar with the other one. If you put u equal to f of x, du is f dash of x dx, shove it into the formula, the f dash dx part is just going to become du. So that's easy. It becomes un plus 1 over n plus 1, plug it back in, and that's it, done deal. So I plan to do a few examples. In practice, you just do it whichever way you can, sometimes by observation, sometimes by substitution. So these vary a little bit. Some of them are already made, so you don't have to make any changes, whilst other ones you have to fill with the constants, and you've got to be careful there as well. So let's do them one by one. The first one, 3x squared, bracket x cubed plus 1, all cubed. We're going to put u equal to x cubed plus 1. You could just go u equals x cubed, but by putting in the plus 1, it makes it easier. du is 3x squared dx. Then you can see the 3x squared dx is up here. That part then becomes just a du. So you remove those two, and this one is just u cubed. Simple. Integrate, sub back, and that's it. Final step is double check it by differentiation. I won't do this one. I'll leave that as an exercise for you. You should be able to differentiate that and show that's equal to the integrand you started with. Okay. Next one, 2x sine of x squared plus 3. So this is one of those which is not a power function. It's a function with another function inside it. So u equals, what do you reckon? X squared plus 3. That's it. Then du is 2x dx. Plug it all in again. You can see there's a 2x there and a dx there. So this one's already made. Derivative of cos is minus. Therefore, it's going to be a minus cos u. And again, check it by differentiating it. So if you differentiate this, you should get that. Next one. Integrate ln x all over x. Now you might recall the derivative of log x is 1 over x. So that should give you a clue already, the fact that it's on the bottom there. If you put u equal to ln x, du is 1 over x dx, so I prefer to write dx on x. And you can see that that dx on x is right there. You just get rid of that, put it a u instead, and then there's the other u there. Now it's easy, just u squared on 2. Easy. Number 4, 3 bracketed 4x to the 6 plus 2 all to the 4, x to the 5. Okay, this one's a bit more interesting. If you differentiate the inside there, you'll end up with a power of 5. So that's the clue that it's reverse chain rule. We just got to fill the constants and make sure they all work out. You just use a u again, or you can try trial and error. Du is 4 times 6, that's 24, x to the 5. And now I look at here, x5 dx, that part there, think of that here. So therefore it's du on 24. I replace it with du on 24. Then you simplify that, bring the 24 out, simplify that more, integrate, bring them together, Bob's your uncle. Easy. And of course, your job is to differentiate this, but this time I've done it for you as well. We're going to differentiate it, okay? So we're going to check that that's correct by differentiating the right-hand side and showing that you get the integrand on the left-hand side. If you differentiate that, the 5 comes down the front, you minus 1 to get a 4, and you multiply by the derivative of the function on the inside. Now make that a dash, that's what it means. That means to differentiate what's inside that bracket there. If you differentiate that, you get 24x to the 5, and there's a 5 there times a 24 there, and that's all going to cancel very nicely. Done deal. Finally, cos root x plus 1 all over root x. If you differentiate root x, you're going to end up with 1 on root x with a constant. So this one is again one of those ones. U equals root x plus 1. We'll put it as a power because it makes it easier to differentiate. Differentiate that, the half comes down the front, subtract 1 from there. I'll put the 2 on the other side for ease. And I rewrite it like this. There's dx on root x, which is the same as dx on root x up here. So instead of that, we'll take that away and we'll replace it with 2 du. So there's a 2 and a du there, and there's a cos of u right there. That makes it easy. That's sine u. Plug it back in, Bob's your uncle. Well done. Thanks for listening, guys, and I'll see you next time. Bye.